Oh. Good morning, Dimon. Oh. Turn on the light. Oh. I'm very tired this morning. Shoot, Dimon. What's your question? Yes, I did. I was gonna send a form. Let me see. That form. Well, yeah, if you want a rec, you just ask. Right, you send an email asking, if I can write one, and I'll give you an honest assessment. I'll say if I can write a strong one, a good one, or I'll tell you if I don't think I know you well enough to write a strong one. And if it is the latter case, then that doesn't mean I won't write one for you. I can still write one for you, right? We'll just have to work together a little bit to get to know you a little better. So it's going to take a little extra work on your part. If that doesn't sound like something you want to, then I'm going to ask you more questions, blah, blah, blah. And if that doesn't sound like something you want to do, feel free to ask another teacher. Once I do say yes, and once we do agree that I'll write one for you, I have other forms in addition that I require all students to fill out too. All right, we have 4 people tuned in this morning. So fun. Who are you guys? Who's Who's tuned in right now? Hello, Sarah. So good to see you. Let me see the classwork. 4 people have turned in the assignment. So I hope we have things to talk about, or if you don't have questions and it's just not turned in because you're procrastinating, that's cool too. Just 1 second. I'm reheating my breakfast. Eric, long time no see. Thanks for waking up so early to catch the stream. 10 o'clock is really late. Conducts a larger amount of current. That's the exact same as saying, oh, the smaller resistor receives more current, right? Like, why is the value of the current in the smaller resistor larger than the value of current running through the smaller resistor? I just decided to write it using a little bit more formal vocabulary, but yeah. Eric, you said you're having trouble tuning into the live streams because you're up too late playing video games. What video games are you playing? The specific is terrific, right? So don't just say, oh, I'm playing video games. Just tell me what you're playing, how long you're playing it for, when you're sleeping, who you're playing with. The specific is terrific. It's like if a basketball coach just yells hustle, that's not really helpful, right? It'd be really nice if the basketball coach said man up and get in his face, get in number 7's face and don't stop following him around. That's a lot better than the coach just yelling hustle. So Fortnite. I thought that was no longer very popular amongst the youth. So you're playing Fortnite, and of course Fortnite's not fun alone. Who are you playing with? Juvenile. Wow, okay. I feel juvenile is both a noun and an adjective, and whenever it's used as an adjective, it's quite patronizing. It's like, oh, don't act so juvenile. Oh, that is so juvenile. I play until 2 or 3 in the morning. Sometimes I don't like to wake up early, but I miss the class. I'll play with some of my middle school friends and sometimes Bronx Science kids too, like Alex. But now Alex broke his Xbox, so I can't play with him. Oh no. Press F for Alex's Xbox. I seem to have misplaced my souls. Now I'm thinking about the tea I want to drink today. Lots of options. I'll go with an old favorite. Cooking. This is actually the first. I think during this whole month, I've ordered food 3 times. And yesterday I was really busy, so I ordered food. And it wasn't very good, so I didn't eat all of it. So now I have leftovers. Eric, you can't even see the easel right now. You mean from the previous videos? Hi, Atune. How's it going? What's the QQT question? I'd love to answer that question, Sarah. Wait, is that like a AP language thing? Qualitative, quantitative translation. I have no idea what that is. But I would love to answer your question, Sarah. So current is a measure of moving charge. Wait, qualitative, quantitative translation. I don't know what that is. And I don't care. I think this year's AP exam is just baloney. I mean, if you guys want to review for it, I'll run a review session, but I think it's just I'm just gonna come out and say that. Yeah, what is current? Current is moving charge. But instead of like looking at one charge and seeing like, oh, how fast is that one charge? Instead, you have to imagine like there is, you know how sometimes a PE coach will stand at one point in the track and like count how many laps you're doing. Like every time you pass by, they'll like mark you like, oh, he did a lap, she did a lap, she did a lap, he did a lap. A current, that's exactly how we measure current, right? It's not, you don't really care about how quickly the particles are moving, the charges are moving, although generally the faster the charge is, like the more current you do have. But what would I say? To calculate current, all you have to do is count the number of charges that pass by your counter person or the device you're using to count it. Yeah, if you guys don't believe there's gonna be like rampant cheating and stuff, like it's ridiculous. Like a bunch of friends could go be in the same room and take it together. It's like it's a desperate ploy from the college board to keep the money that you've already paid them. If I was in your shoes, I'd ask for a refund. There are lots of motivations for taking the AP exam, right? I remember when I was in high school, why did I take AP exams? There are a lot of reasons, right? I think one of the more important reasons for a lot of us is that if you score high enough, you can get credit for college classes, and in some cases you can graduate in 3.5 semesters. Some others 3, and some really rare extreme cases you can graduate in less than 3 years, and that saves a lot of money. I, for one, am in the belief that, and that's not for everyone, right? And in my case, unfortunately, I took a lot of AP exams when I was in high school, and by the time I got to college, my college didn't accept any of them for credit. And I was like, cool, what a waste of time. But besides that, I mean, that's me specifically, right? But I think something that'll apply to all of you is that I think if I was in a college administrative board, I would not accept the 2020 AP exams for credit. Not only are they really short, like 45 minutes, not only do they only cover like a fraction of the course, so why would you give full credit for the course? But it's just not a secure exam. So, I mean, I wouldn't. There are other reasons, right? Some people like to have a goal. Some people look at exams as a form of external validation, like, oh, if I score a 5 or a 4, that means like that's really good, right? Like if I score a 4, that puts me in the top like 15% of people in the whole world that took this exam. And and that itself does have some value, but um that's not how I would really approach it, right? Like that's what I'm saying, right? And you don't need a test to show you how much you've known and um, show that, right? Art, you can experience that in class, right? Through our reflections together and our conversations and our discussions. Like, that's where you can show me how much you know, how much you're learning, how you're thinking. And I think and there is the value, I think. Exactly. When you see something happening in the physical world and you're able to explain it, boom, that should be all the motivation and validation you ever need, right? It's like, oh, like I did learn how to explain something like that, right? And explain it. Happy Passover to my students who that applies to. I'm all about the one person seders right now. That's my life. It'd be like that all the time. Today we have Ayana Kabuse, which is a shaded sencha. But unlike Gyokuro, which is shaded for around, oh yeah, which is shaded for, I would say, 20 days to 24 days, Kabuse is shaded for much for a much shorter period of time. It's around 10 days to 2 weeks. So its flavor is somewhere in between a sencha, a regular sencha, and a gyokuro, which I think is really good because while gyokuro is frequently referred to as the king of Japanese green tea, right? It's like you have to shade it for like three weeks or more. That takes a lot of labor. Like workers have to like pull like shades over the bushes and stuff, and the harvesting is a little different. Um, its flavor is sometimes so sweet. Some people say it's too sweet, um, which is why we have kabuse, which is somewhere in between. And that's something I can drink every day. Gyokuro, I could not drink every day, right? It's just too decadent. It's definitely a Sunday tea. Uh, why not take the best possible tea flavor and mass produce that? Because some things aren't scalable, Dimon. And things are subjective. My favorite tea may not be Itamar's favorite tea. So if we both have different favorite teas, how do you decide which one to mass produce? Random physics questions is all we're about. Sarah, if you have any more questions on current, like if that explanation wasn't satisfactory, let me know and I can answer it a different way. If you're still in the chat. On Itamar, yes, please ask a random physics question. Dimon, Arizona iced tea is not even tea. It's sugar water with citrus flavor added. Not that it tastes bad. I grew up on 99-cent cans. But it's not tea. Okay, fantastic, Sarah. That's good to hear. And you know the best thing? These leaves, you can eat them with rice if you put them in a ponzu sauce. So I'm going to make a ponzu sauce, put my tea leaves in there, and then eat it with rice. Yum! I was riding my bike, and I used the right-hand rule and noticed the torque pointed to the left. All right, so with that, Itamar, the torque, I don't know what you mean by the torque, right? Because torque on your bicycle only exists while it's changing speeds, right? If all the wheels have a constant omega, then there's no torque, right? Because there's no alpha. There's no angular acceleration. And this is a good review for all of you in the stream right now, because we're reviewing angular mechanics. So what you do mean is when you're riding your bike, the omega points to the left, right? If the wheels are rolling forward, then omega points to the left. And the harder you pedal and you speed up, then alpha and the torque will also point to the left. And if you slow down, yeah, exactly. If you slow down. So torque, you have to think about it as a vector, right? If my omega points to the left, is this pointing to the left for you guys? Okay, so if if your omega points to the left, right, which means you are rolling this way, right? Whoa. And my omega points this way. And then my torque also points to the left. Torque is not force, right? So if my force pointed to the left, of course I would veer this way. There's a force pushing me this way. But if there is a torque going this way, all torque is it's just linearly related to alpha, right? So forget about torque. If torque points to the left, alpha points to the left. If omega points to the left, alpha points to the left, all that means is the omega's magnitude is going to increase in this direction. And all that means is omega gets longer it gets larger, but it doesn't change direction. For something to turn, the torque has to point in a different direction than the omega. Torque and alpha are always pointing in the same direction, yes, just like how net force and linear acceleration point in the same direction. It's just a description, right? Like, that's the saying, oh, if omega points to the left, why isn't the thing rolling to the left? Right? So, yeah, it's not in any way describing like where something's going or where something's getting pushed towards. Okay. Ichimar just asked a great question. So, when I had that bike wheel, right? Oh, here's the sauce. Oh my. Oh, yum. So let me see if I can find a wheel thing. All right. So I have this cast iron lid here, and if it's rolling, and I put my finger here, right, I would argue that it can stay like this, right? And we saw that, and Dimon wasn't able to hold it up because he's weak. No, he couldn't hold it up because it wasn't spinning. I want you guys to think about why I want you to remind yourselves like why that works. Like, why can the wheels stay on my finger like this if it's spinning, and why will it fall if the wheel isn't spinning, right? That was a demonstration of one specific angular quantity in particular. Don't put it in the chat, but just think about it. I'll give you some time to remember. All right, so if you guys remember, if you don't, it was angular momentum, right? So when this spins, I don't care which direction it's spinning, right? Let's just assume the angular momentum is pointing this way, right? Why doesn't it tip over? Well, because the angular momentum points this way. And if angular momentum is conserved, it's going to keep pointing this way. And it doesn't want to point down, right? The direction is also conserved. So why does it rotate, right? Why does the thing spin like this then? The answer is here. If I treat this as my pivot, right here, right? And the center of mass is around here, then the force of gravity points down and there is a torque. There is now a torque on this wheel. Okay, but check this out, right? Where does the torque point? The torque points into the page, right? It points towards me. So what I have here is the angular momentum points this way, but the torque due to gravity, so my angular momentum is blue and it points, okay, so the angular momentum points this way and the torque, right, I'm gonna put this down. The angular momentum points this way and the torque points this way. And if torque times time is change in angular momentum, torque is going to tell you where the angular momentum will point later, right? So if my torque points this way, that means my angular momentum will change in the direction of the torque, right? That's why it spins. That's why it changes direction, right? Because my angular momentum will change just according to my torque, okay? And my torque is telling it to go this way, right? Why doesn't the bicycle change? Well, because the bicycle's angular momentum pointed this way, but the torque pointed this way. So it's not going to change the direction of my angular momentum. It's just going to change the magnitude, right? Here, the torque will change the angular momentum's direction and not its magnitude, right? So it goes this way. If you guys are curious as to like a more in-depth explanation of that, you can look up. It's called precession. Okay, I think there is a whole Wikipedia article on it. I don't know. Let me see. Precession. Yeah. The one we did in class is called gyroscopic precession, right? Yeah, I hope that answered your question, Itamar. Yeah? Any other questions? On any topic of physics. I mean, you guys can use this time to sneakily prepare for the AP exam if you guys aren't, if you're in the camp who aren't asking for a refund. Thank you, small master. Okay. What did we say about the Magnus effect that day? The Magnus effect was a really cool way to look at how, or the cross product shows itself in real life for something we can see, right? So if my velocity points some way, like, so if I have a ball, right, and it's rolling towards my, so if I throw a ball with you, if I throw a ball to you, but I throw it with some top spin like this, right? Most people throw like this with backspin, but if I snap my wrist this way, I could throw with topspin. That's how a curveball works. Am I right? When that happens, then I can say my angular velocity points this way, but my linear velocity points this way. And if I say my force is, hold on, wait. Yeah, if my force is omega cross v, then if that's omega and then this is v, the force will point down. And that's how it does happen, right? It will experience a downward force. So what happens to the ball is it falls down in a trajectory that's a lot sharper than what it would be doing under normal parabolic motion. Now, if I throw it with backspin, which is like a common way to throw a fastball, right? Right, like this. Now my angular velocity points this way, and my linear velocity still points this way. And omega cross v gives this. The force is now up. And you will see that. It's actually possible to throw a ball so that it doesn't sink at all. If your omega and your v, if your omega is high enough, like you're spinning really fast, and your linear velocity is high enough, then the upward force you experience can equal gravity, and it'll just travel in a straight line for something with backspin. The thumb is always the force in these signs, kind of. When I say A cross B equals C, I go A, B, C. And a lot of our formula is like the force equals the cross product, or the torque equals the cross product. So that's why it always ends up being our thumb. But just remember, it's non-commutative. If it's A cross B, this is the direction of A, this is the direction of B, right? And that's the direction of their product. Okay, as for any cross product. So the example of the Magnus effect was used to highlight that the cross product is not just this mathematical thing. Like, it's really useful when you're trying to model things like the Magnus force. Like, yeah, because if you think about it, like if it's moving towards you and it has top spin, if someone throws something to you and from their perspective it looks like it has backspin, from your perspective it looks like it has top spin. So it's really hard to come up with a rule for like where the force will point, like based on top spin and backspin, and don't even get me started about side spin, right? So if I throw it this way to you, and I throw it with some side spin, yikes, all right? Well, the force is now going to point this way, right? And omega is pointing this way, v is this way. And that's like extremely hard to describe without the vocabulary, the mathematical vocabulary that we have from cross products. In common magnets, are the charges always moving? Yes. But they're spinning. They're not like, it's not moving like a current, they're spinning. Is the best model we have? Do we really know what's going on a microscopic level for these electrons? No, because we don't even know if they're particles. All right, we just went from 10 concurrent viewers to 12 concurrent viewers. Those 2 new people, can you say hi? I just want to know who you are. We will be going over the double slit experiment in May, okay? Cool your jets, Timon. Don't we know? No, we don't. There's a whole study of physics about what a particle really is anyway. Like, what is a particle? Something with mass that can be touched, that can, something that occupies space and has mass and volume and stuff like that. Like, what is even a particle? Ainava, hello. Hi, Jacqueline. Hey, Justin. All right, so no one has any questions on the reflections. So even though there are only 4 turned in so far, I'm expecting 100% turn-in rate by tomorrow at 11:59 p.m. I hope so. The reflections are being graded. They are. I'm going to read every one of them. Mr. Ross is going to help me read them. And my Regents class had something similar. That was like one of their very first assignments. And it took a while to grade, but we got there. Right? I am kind of confused, but I do not have specific questions. Well, Sarah, if your confusion manifests itself into more concrete questions later during the day, you know where to reach me, right? seoha@bxscience.edu. Let me see. Let me write mine in my head right now. Why does the larger resist? Okay, there's. Well, they can be 2 sentences each. And they can be as long as 4 sentences each. A paragraph is not 4 to 5 sentences, right? A paragraph is a complete idea. That's it. My first one is 5 sentences. A tune, I would argue that's a little too long. But did you turn it in already? Let me see. You have not. So, I mean, I would like to read it and see where all those sentences are. No, Attune, there's no such thing as like the right number of sentences, right? I'm just going to read it, and if I feel like it's too long, it's too long. And if I feel like it's too short, it's too short, right? I want you to be able to completely express your idea and your thinking and your reasoning. That's the thing, okay? It's never about the numbers. And if you're reading it and you feel confident that it's a good response and that you're explaining yourself clearly, go for it. If I read it and I find an unnecessary sentence, I'll let you know. I'm not going to like dock off points, but I'll let you know, right? Just so you can improve your writing moving forward. Is light apart? Bro, everything. Okay, so Dimon, with that, you're really moving ahead. I'm going to ask you to calm down a little bit. Great, Ainava. Dimon, every particle is a wave until it is observed. Look up wave-particle duality, okay? Thank you for being a reassuring force during this trying time, Ainava. for your classmate. Thank you so much. Here's a question I have for you. Dimon, that is a question that we're still struggling with. There is a really good video on this. I think it's on PBS Spacetime. PBS Spacetime. Look up the observation problem. Right? It's I don't know. It's this YouTube show hosted by this theoretical physicist from Australia, Dr. O'Dowd, and he has a lot of cool videos on his channel. Is a lot bigger than mine. The wave nature of things does have something to do with the Heisenberg uncertainty principle. Yes. Well, guess what? Dr. O'Dowd is a frequent collaborator of Dr. Neil deGrasse Tyson. So, Dr. O'Dowd actually works at Lehman. And he works at the American Museum of Natural History, where he and Dr. Tyson frequently collaborate, right? So, yes, Eric. I love questions. But then after this, I have a question for you. Okay, all of you. All right, Eric, you can ask your question. Chris, what did you learn yesterday that was so amazing? Lululemon. What did you learn, Chris? Tell us. In high school? Yes, the story of Okonkwo and the yams. I think we're all familiar with Things Fall Apart. Chinua Achebe was a professor of literature and writing at my alma mater. Before he passed away. I didn't take a class with him, though. What is being a physics major like? I think it really depends on where you go. I was lucky where I went, and that specific cohort, the class of 2014, it was a good group of people. It wasn't very competitive. We helped each other a lot. And I feel like everyone who's studying physics actually enjoyed physics. And I don't think and really wanted to study physics. And it's not the same for other STEM fields. For example, like if you see like biology majors or biochemistry or biomedical engineering, those all sound like very stereotypical pre-med majors. Not that I have anything against like doctors, right? Especially now. But what I'm saying is like the people in your classes and in your major may not necessarily really are that interested in biology from a purely intellectual standpoint, right? They're focused on getting into medical school or pharmacy school or stuff like that, right? Whereas anyone studying physics is usually just in it for the physics. And I think that's something that's really nice. And it means you're surrounded by people that really care. I would argue the same goes for math. pure math, not applied math, right? So in pure math, like all of your classes will be proof-based and stuff. It's not about solving equations, it's about proving an equation can exist for like a certain type of equation or something. That's all I can say about it, right? I'm not going to say like it's harder than other majors, that it's more work. Every major is a lot of work. Every major is difficult, right? Okay, not everyone, but the ones worth studying, right? Can you pursue physics as a hobby, not a major? I don't know what you mean by that. I mean, like, anytime you look at the world and try to examine it, or like look at these videos on YouTube that you're talking about and stuff, that is a hobby, right? And everyone has the ability to be a amateur physicist, right? All that entails is looking at the natural world and thinking about how it works. Later in life and not in high school. Interesting. I'm not sure about Professor Achebe's career trajectory. I'm sure he's been everywhere. So, yeah, that's cool. I would have loved to have taken a class with him, but I was too busy taking physics classes, right? Uh, and I'm not in any way knocking on people pursuing like pre-professional programs, like if you intend on going to law school and you're like a history major, you know, or if you intend on like trying to work for Google or Facebook, and you're studying computer science, and you're studying computer science not because you're interested in computer science and like the theory of computer science, but just more the practical application of it, right? I'm not knocking that, right? I mean, that's a totally legitimate way to like leverage an education to like get to like where you want in life. What I'm saying is there's a certain refreshing quality to the community when people are in it for the field of study itself. You see that in philosophy classes, you see that in physics classes, you see that in pure math classes, you see that. I feel like in a lot of writing workshops too, right? Like writing seminars where there are like 10 people in your section and you just share writing and you offer critique. No one's going to these classes because like, oh, it'll make my application look better or something, right? They're just in there because they like writing and they want their writing to be critiqued. What do I think about the philosophy of Stoicism? I think, like a lot of other philosophies, Dimon, it's frequently misinterpreted. I think Stoicism in itself has a lot of negative potential to reinforce certain. Stoicism itself has a lot of potential to negatively reinforce uh, certain stereotypes about masculinity that are not very healthy, right? About like toughing things out and stuff. Yeah, and it's frequently misinterpreted and under misutilized in that vein. But I do think it does have some valuable lessons to teach. Um, and right, like you have to keep faith in that things will get better, things will get worse, and that's the nature of things, right? And the goal is to endure. My second cup. Oof. Unfortunately, Ayanaba, the DOE has banned Zoom. But you know what? I'll talk to Luca and Maxine about that. I think that'll be really fun. We can definitely hold a philosophy club meeting either on this channel or some other format. I am really going to think about it. We can do Google Meets. I think you don't. I think that would be super fun. Itamar, not only can you sit in on that, you can participate. I'm pretty sure you have a lot to contribute. Yeah, something like that. I'm just afraid about how many people will come. And I think if we're more than 20, the Google Meets will kind of like crash. We'll see. We'll see. Yeah. I'll talk to Luca about it and Maxine for sure. Sounds like a great idea. Thank you for bringing that up. I know, Sarah. There's too many clubs, too many activities. Oh, it just got on my leg. Every little thing gonna be alright. Smell this, guys. Ready? Mmm. Yum. Yeah, I really did think that was a very fun meeting. Remind me was that on hedonism? I thought that was a very invigorating discussion. That's how you spell Aaron. Interesting. It was. Awesome. All right. Well, guys, if there are no real questions about the thingy thing, right, which was what? Thingy thing is the reflections on the circuits. Make sure to email me if you do. I guess we'll say goodbye. Tomorrow we will be making Chris Morocco's from Bon Appetit, his shortbread recipe. We're gonna make cookies. So get pumped. And we can talk about anything. Maybe we'll even talk about hedonism. I think that's very closely related to cookies and their consumption. Okay, so I look forward to seeing you guys tomorrow. Today was an office hours about the reflections. Didn't really happen. Tomorrow is open office hours, kitchen hours. Okay. Have a great day, everybody. Be sure to relax. I hope you're writing. Let me post some more resources. If you guys are really interested in like just making the most out of your time, for instance, ClassCentral.com offers a bunch of like over 1,000 free courses offered by universities. And they're all online. Some of them have quizzes, all of them have readings, and it's like a really great way to learn about something you're interested in. Here is a course I was thinking about looking at just to like brush up on it myself. All right. It's a class about Plato and ancient Greek philosophy. I mean, I already have Aristotle's Nicomachean Ethics and Plato's The Sophist and Theaetetus, among other books. And I've read these, but I just feel like I'd like to see the perspective of someone else who's teaching the course. So there are a bunch of courses on this. It's not just about philosophy. So Diman, what do you think is the optimal way to govern a society? Or do you agree with Plato's assertion that every form of government will eventually fail by its sole defining characteristic? right? Democracy fails due to mob rule. Oligarchies fail due to the overaccumulation and concentration of power and wealth. Theocracies fail, right? So are you in accordance with that and like kind of approaching it from a defeatist attitude, or do you think there is actually a solution? So you absolutely do agree with him. All right. You should also recommend books for us to read, but aren't you guys reading Invisible Man? Are you done? I'm not going to interfere with the reading that you already have to do, but I would love to recommend The Three Body Problem. Fantastic book. Here, things that are related to American studies. I think this is an extremely important book for anyone who wants to think critically about the world. It has Dr. Abrams' favorite word in it, community. And it talks about the rise of nationalism, right? Because what are nations but just imagined communities, right? So these two books are great. I did bring up this one in the previous office hours, right? This one's a lot lighter, and I think it's cool. Mr. Ross likes that one too. Other favorites? Let's see. If you're in the mood for nonfiction and essay writing, Rebecca Solnit, also really solid. She's much more famous for another book, Men Explain Things to Me, right? And she coined the term mansplaining in that book, right? You can tell me all about that debate later. But yeah, Imagine Communities, extremely important book that everyone should read in their lifetime, right? If you're looking for more physics-y books, talking about the beauty of physics, one person who I'd highly recommend is Carlo Rovelli, The Order of Time. He also wrote another one about like the strangeness of the quantum mechanical world and how small it is. He is a practicing theoretical physicist. He is at the forefront of a lot of the research for theories of quantum gravity and loop theory. But he also has the ability to write very beautifully in prose about physics. Okay, let me see if I can read you my favorite passage from this book. Is it from this book? Hold on. Okay, I gotta look at this. Quantum time. Oh, yes, page 95. Okay. Listen to this passage. It is beautiful. Okay. Are you ready? We can think of the world as made up of things, of substances, of entities, of some things that are, right? Or we can think of the world as made up of events, of happenings, of processes, of something that occurs, something that does not last, and that undergoes continual transformation, that is not permanent in time. The destruction of the notion of time in fundamental physics is the crumbling of the first of these two perspectives, not of the second. It is the realization of the ubiquity of impermanence, not of stasis, in a motionless time. Thinking of the world as a collection of events, of processes, is the way that allows us to better grasp, comprehend, and describe the world. It is the only way that is compatible with relativity. The world is not a collection of things, it is a collection of events. Here is the most beautiful part. The difference between things and events is that things persist in time, while events have a limited duration. A stone is a prototypical thing. We can ask ourselves where it will be tomorrow. Conversely, a kiss is an event. It makes no sense to ask where the kiss will be tomorrow or where it was yesterday. The world is made up of networks of kisses, not stones. How beautiful is that? While that was extremely poetic, right, to say that the world is made up of kisses and not stones, I want to kind of talk about what he's really saying, right? He's talking about the world is not made up of objects, but it's made up of interactions or events. So in the context of our class, it would be more like the world is made up of forces and not events, right? Because how do objects really interact with each other? Forces, right? Newton's third law. So you can view the universe as a collection of interactions rather than a collection of things that interact with each other. Because what would the universe be without any interaction, right? If a bunch of objects just existed and didn't interact, then nothing would happen, right? You wouldn't even be able to be thinking. You wouldn't even be able to be conscious, because conscious thought involves electrons moving in your brain, and that comes from forces that are acting on your electrons and stuff. So that's what he's saying when he's saying the world is made up of kisses and not stones, but in a very beautiful way. So he writes very beautifully about physics. So those are the 4 books I'd recommend for you. The Order of Time by Carlo Rovelli. The Three-Body Problem. Okay. Benedict Anderson's Imagined Communities. And Daniel Quinn's Ishmael. Yeah. Okay. All right. The last one being the lightest of all everything. Would I recommend Stephen Hawking's books? Yes, if they interest you. I don't think they're as beautifully written as Dr. Rovelli, but Dr. Hawking is probably one of the only people in the world that can write about what he's writing about with the level of understanding that he has. Like an interdisciplinary class that overlaps physics and English. That's interesting to say, Sarah. I would like that to exist as well. Okay. Now I should go, all right? Bye. Have a great day.